Hello everyone, my name is Debashish Roy. I'm the head of training and development at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar today. And today's topic is EIGRP Advanced Concepts. We'll talk about Stub, EIGRP Stub, and EIGRP Summarization. So we all know that EIGRP, Enhanced Interior Gateway Routing Protocol, is a Cisco's protocol, that is the routing protocol. Previously it was Cisco proprietary, now it is open standard, but we'll not talk about the basic features much here because we'll be talking about the advanced features, that is the IGRP stub configuration and the summarization. So let's begin. So what is the stub, EIGRP stub command? How to use it? Where to use EIGRP stub? And where to summarize the routes? It is used for path optimization and route summarization. But how it is done? Let's see. So we'll start with the EIGRP. What is the EIGRP? It is a routing protocol, Cisco's routing protocol, that's an enhanced interior gateway routing protocol. And it is a Cisco's proprietary routing protocol that effectively integrates the benefits of both link state and distance vector routing protocol. Means it is a advanced distance vector protocol. Somebody said it is a hybrid routing protocol. It is true because it has both features of link state and distance vector routing protocols. Like link state routing protocol, it has the neighbor table, it has the topology table, and like the distance vector routing protocol, it actually advertises the routes to the neighbor routers. So this is the feature of both link state and distance vector. So that is why we say that this is a hybrid routing protocol or an advanced distance vector protocol. So this design enhances efficiency and scalability because it is a very scalable network. In a scalable network, you have too many routers or too many nodes, and for that, EIGRP is a perfect choice. Now you'll understand EIGRP basics now, and that what is the EIGRP, why it is used for stub networks, why it is used for route summarization, these things. So stub networks enhance routing efficiency. Stub means what? You are blocking some, say, information or the update. EIGRP utilizes advanced concepts like stub networks to optimize route management, because every now and then, if you just advertise updates or messages, then definitely it will flood the networks with too much traffic. So a stub network is a segment that connects to only one other network and does not forward traffic to other networks. Like if you're, say, having an interface down issue on a router, then what will happen? The router will flood all the information to the other routers. Say there are 5 EIGRP neighbor routers, so all those 5 routers do not need to receive the updates. But if you do that, then there will be too much traffic. I need to block that update. That is where you can use a stub. It simplifies the routing decisions and reduces the complexity. Route summarization, on the other hand, improves efficiency. Route summarization in EIGRP reduces the number of routes advertised, because say you are having hundreds of loopback interfaces on a router, then you can advertise those, and one by one it will be advertised to the other router and it will be seen in the routing table. Now definitely that is not efficient, because then if you want to perform the routing there one by one you have to do it, and definitely it will take a lot of CPU power. So you can summarize the route. You can combine multiple contiguous subnets. Contiguous means that it is having some common bit patterns, like 192.168.0, 2, like that, means serial. This leads to a more efficient routing table and decreased processing overhead. So that is why route summarization is done. Now, what is a stub network? Let's understand. A stub network is a type of network configuration where the network does not route traffic to other networks, functioning as an endpoint. It is a single entry and exit point network, means there is a single network that is connected to the other network. There are no more networks connected. And this topology simplifies the routing process by limiting routing information to only one other connected network, reducing complexity and making it easier to configure. What are the types of stub networks? You have totally stubby network, you have the stub network definition, and the not so stubby network. But definitely, this totally stubby and not so stubby is more related to the OSPF protocol than the EIGRP. But you could configure this totally stubby and not so stubby in EIGRP also. But the main concept is the same, that you are blocking some updates. Some updates is coming from the other router, and you are not allowing it to pass on to other, let's say, autonomous system of EIGRP. That is the stub area. Now, what are the benefits of stub networks? It reduces routing table size. So, stub networks significantly reduce the size of the routing table by limiting the number of routes that are maintained, because otherwise the routing table will be overwhelmed with the routing updates and it will be like the flooding. This simplification not only aids in faster routing decision but also enhances overall network performance in the EIGRP. Second, it decreases routing update traffic by minimizing the number of routes and updates exchanged. Now, the stub networks lead to a decrease in routing update because you have to make sure that all the routers participate in the neighbor election, but the routing traffic is minimized. Otherwise, the routing, say the synchronization time, the convergence time will increase. This reduction enhances bandwidth efficiency and lowers the likelihood of network congestion. Now, simplifies network design, that is another way. Stub networks contribute to a more straightforward network design by limiting the complexity of routing protocols. Because if you are using a stub network, then it is blocking some updates and it is simplifying the design. Otherwise, it will pass on all the updates and maybe you'll be confused of the routes because there will be too much routes there. This simplification facilitates easier management and troubleshooting of the network. Then let's come to EIGRP route summarization now. Now, EIGRP route summarization condenses multiple contiguous routes that I have already told you into a single summary route, which simplifies the routing table. So first, if you do the routing, you will see that all the routes are actually sent individually. And now, if you do the summary, then it will be a condensed route that will actually, it will be a bunch. Like it will be a bunch, it will actually have all the routes in it, but not individually. This not only decreases memory usage or CPU usage, but also minimizes the frequency of routing updates because routing updates should not be frequent. Now, how to configure route summarization? First of all, you have to identify routes. You have to determine the contiguous routes that I have talked, the specific routes that can be summarized based on the network address, because discontiguous routes are there. They cannot be summarized. That you cannot summarize like 192.168.1 and 192.168.10. You cannot do that. Apply summarization command. What is the command? IP summary address EIGRP and the ACE number, and that is interface specific command. Then the verification of configuration. You have to check the routing table with the show IP route command to confirm successful summarization. So what are the best practices for summarization? You have to summarize at major boundaries, and you have to limit summarized subnet count and test in lab environments. So you have to test all these things before actually applying it in practice. Now you can combine stub and summarization both in order to achieve the best result. Now, what are the benefits of stub network? Stub network limit the routing information exchange between routers, which simplifies the overall routing process. And route summarization consolidates multiple routes into a single route entry, which minimizes the size of the routing table. They both are two very unique features to minimize the routing updates. So you have to combine. That is the best practice. Now, what are the case studies and real world applications of these things? In 2021, a large enterprise implemented EIGRP with stub networks to enhance routing efficiency and minimize update traffic across its regional offices. In 2022, service providers adopted EIGRP route summarization to streamline their routing tables and improve performance for client networks. And 2023, a case study revealed performance improvements in a multi-site organization using EIGRP with both stub networks and summarization, leading to quicker convergence times. So you can see that these are the applications of this EIGRP stub and EIGRP summarization in the production environment. And that is about the theory part that I've told you about the EIGRP stub and summary. And now let me take you to the GNS3 console here. As you can see, there are two routers connected. The IP address is not there. Let me just switch on the router first. As you can see, the routers are powered on now, and you can configure IP addresses on the first interface. Also, on, let's say R1 or any one of the router, you configure a loopback interface. So let me configure the IP address first on the R2. The routers are just booting up. Okay, and now you go to the config mode and interface F0 by 0, say 1001, and I'm not creating any loopback here. I'm creating it on the R1. Here I'm giving 1002 interface loopback 0, and I'm giving 192.168.1.1 and the default mask, and I'm creating interface loopback 1 as well, and I'm providing IP address 192.168.2.1. Now you configure EIGRP like router EIGRP and AS number, let's say 1, and you advertise all the networks 0000 using the wildcard mask. On the R2 as well, router EIGRP 1 and the network 0.0.0.0. Now you shut down the one of the loopbacks. So exit and you go to interface, let's say loopback 0, and you just shut down. Before that, you give the command on R2, debug command, debug EIGRP packets query. Switch on the debugging of the packets, and on the R1 you just shut down the interface. So now you have got the query. This is the query that was initiated by the R1 to R2. You can see that it is informing it. The 1002 is informing it. Now this message I want to stop. So what I can do here on R1, you again give no shut command on the loopback, and now on R2 you go to router EIGRP 1 and you give EIGRP stub. So actually the neighborship is rebuilding with the adjacency rebuild. And now if I go to the R1 again, and if I go to the loopback that I am here already in, and already again I shut down. Have you received that message here? No, I haven't received any message this time, because what is happening, the stub is actually prohibiting the message to enter the EIGRPS, and that is the feature of the EIGRP stub. You could advertise the connected networks, you could advertise summary route, you could advertise only static route, but in this case it is preventing any update from the directly connected networks. So that is the EIGRP stub feature. And also in R1 you have the two loopbacks. Now in the R2, if you go to the show IP root EIGRP, then you will see that 192.168.2.0 is advertised because the R1 is down. So here if you give no shut, so the loopback will be up again. And here if you go, you will see 191.1 and 2 both are advertised, but I want to summarize these two. I do not want to receive individually these two, so I can achieve summarization. So just go to the R1 and go to the interface F0 by 0 and you give IP summary address EIGRPS number 1 and give 192.168, let's say it is 1.0, and the summary mask will be 255.255.252.0. This would be advertised only. So as soon as you configure it, a message is there, summary configured. So now go to the R2 and you can see it is messages coming that the summary is already there, sending the summary route. And now if you go to show IP route, you can see that only one summary route, that is 0.0, actually it is summarized to the class boundary. We gave the 1.0, but actually it's summarizing to the class boundary because the auto summarization is on. So that is why it is summarizing to the class boundary. If you give no auto summary, then it would switch off the summarization. And you can see /22 CIDR is advertised. So we have achieved the summarization. So only the summarized route is there. This is the packet, this is a bunch, you can say. Within that 1.0 and 2.0 networks, these are there. So this is how you simply configure the EIGRP stub and EIGRP summarization, the route summarization that you see. And summarization is not only there in the EIGRP, but that is there in the OSPF, that is there in the BGP, the Border Gateway Protocol. So that is about the practical part of this stub and the EIGRP, the summarization. So these topics are a short topic, you can say, of the CCNA and especially the CCNP NRC. This is not a very big topic, but this is a very important topic for your routing protocols, because you want to suppress the routing updates in order to stop the flooding. Like in case of OSPF, LSA flooding is stopped by introducing the concept of areas. You are dividing autonomous system into areas, but in EIGRP, we do not have that concept of that area. So how do you do it? How do you suppress routing updates? By using this stub feature and the summarization. These two features are very important for this EIGRP. So EIGRP, maybe it is not used as much as the OSPF, but still EIGRP is a very crucial protocol for your CCNP studies, and also it is an open standard now, so it is used more nowadays than ever before. And if you are aspiring, say, the Cisco certificate, or if you're going to plan for a Cisco certification, or you are a network engineer, definitely you should learn this Cisco, this network topics very meticulously. And EIGRP is definitely a protocol that you cannot ignore. Because in Cisco Blueprint, in their NRC and NCore also, and also in case of CCNA, although it has only OSPF mainly, but still you have to have some knowledge on EIGRP, because EIGRP was a Cisco's own protocol for a long time, and a lot of questions come definitely from that EIGRP. Even in CCNA level, 1 or 2 questions will come. So that is why this topic is a very important topic for your studies on Cisco level, and also you can implement it as a network engineer in your production line. So that is about the topic that we have, and I have a very good news for you, that there is a contest running on, and there is a questionnaire that is shared with this webinar, and there are 10 questions, and there are very easy questions that you should attempt. And if you give, say, 8 out of 10 correct answers of the questionnaire, you'll be eligible for the certificate. So just think about it. This is a very valuable certification that you can achieve by simply giving correct answers. And this study for the Cisco certification, that is very important for your career, and CCNA, CCNP, these courses are very important. And as a very senior trainer of this institute, I personally take these classes, and I actually recommend everybody to join as soon as possible to actually enhance your career level. And Cisco, as you know, that is the greatest level of the networking. And as you know, networking is the foundation of every technology. So everybody should learn the networking to actually enhance their career prospects. And also, if you enroll this course, then you will receive a flat 10% discount today itself. So everybody should enroll it as soon as possible right now. So that is about the topic EIGRP, advanced concepts, stub and summarization that we had today. And I actually discussed everything about this topic, the theory and the practical. And I hope that it was very helpful for your studies and also for your studies and also for you to apply in your environment and in your enterprise level. So that is it from me about this EIGIB advanced concept topics today. I'll come with some new topic next time. Till then, keep studying and bye.